Next speaker is Robert Oliva.
Hi, well, my name is Robert Oliva, and the title of my talk is There is Plenty of Room Under Pressure. The aim of this talk is to give you an insight on the science of high pressure and also try to show you that high pressure is a very multidisciplinary science. So, first of all, what is high pressure? The answer is that it depends on the scientific field. For instance, in the case of food technology, food can be processed by using pressures up to 0.1 gigapascal, which is 1,000 atmospheres. And for instance, you can process, let's say, you can cook food. For instance, you can cook lobster, you can cook guacamole, you can also preserve some kind of different cheeses. And in a process that is called pascalization or Bridgmanization, thus preserving the flavor of the food and also to improve the quality of the food rather than using temperature. Also, biologists use high pressure to study how life survives or behaves at different pressure ranges, and they found out that bacteria can survive pressure up to 1 or 2 gigapascals. In my case, as a material scientist, we also use high pressure up to 10, 100, or even 200 gigapascals in order to observe changes in the electronic structure of semiconductors. But also geologists are very interested in high pressure because they need to know what's going on inside the Earth, how minerals transite, have different phase transitions, so they will study pressures up to 364 gigapascal, which is the pressure at the center of the Earth. And finally, it's also very interesting for planetary science to understand what's going on inside big planets. For instance, here you have Jupiter, and you can see an aurora borealis, which is accounted by the abnormally high magnetic field of this planet. And this is believed to occur because of the metallization of hydrogen. It was predicted in 1935 that hydrogen would be metallic at very, very high pressures, but it has not been experimentally measured up to the date. So probably the holy grail of high pressure physics is to find and understand the metallization of hydrogen at high pressure. So when do we use high pressure? Well, as you know, pressure is a thermodynamic parameter, just like temperature, that allow us to vary or modify the volume of a solid just like temperature, but in a much more efficient way, because we will not have the undesired effects of temperature like melting, so that 1 gigapascal is equivalent to 1,000 Kelvin degrees in terms of change of volume, more or less. So regarding to this, it is possible to study or better understand atomic and molecular bondings. And also, it is possible to synthesize novel materials. For instance, from graphite, we can obtain diamond, which is completely different material, still made of the same chemical elements. But also, the chemical elements of the periodic table will behave differently at high pressure. Most of them will go metallic. And even noble gases can react with hydrogen, for instance, to form crystals. Owing to all this interest, Percy Bridgman won the Nobel Prize in Physics in 1946 for his contribution to develop high pressure techniques. So how do we generate high pressure? There are many different ways. We can use projectiles, explosives, multi-anvil cells to multiply the pressure. That cell over there is bigger than a person. But in general, the higher the pressure we want to get, the smaller the volume we have available. So typically, one of the most used devices is this one is the one that I use, which is called a diamond anvil cell, and it consists of 2 diamonds pressing a metal, and inside this metal we have a small hole, and this hole we fill it with some liquid to act as a pressure electrostatic media and the sample that we want to study. So why is it interesting to use high pressure? Well, the thing is, diamonds act as optical windows, and so we can perform almost any kind of optical experiment like absorption, fluorescence, luminescence, Raman scattering, X-ray diffraction, or also even electric contacts to perform Hall effect measurements, for instance. So, to sum up, as you can see in this train, everybody fits in. There's a biologist, there's a physicist, there's an astronomer. So I encourage you to add some pressure in your life because there is plenty of room under pressure. Thank you very much.